So last day we ended our discussion over here. We have discussed about the LL1 parsing table design and how LL1 parser works. We have seen. So with respect to the different type of parser, if we go back to the tree over in previous classes over here, you see that we have actually discussed about one of the top-down parser and another top-down parser left, that is recursive descent parser. So the topic for today is recursive descent parser. Now see, in this particular name, if you closely look into the name, we have the first word is recursive. That means somehow there is a form, I mean the grammar or the parsing algorithm is expressed in some form of recursive function, right? At least intuitively we can understand this. Now how it works and the in greater detail we will obviously understand, but let's try to realize with an example first. So suppose we have a grammar, something like say the grammar is AS2 ASBS. Okay, ASBS, or maybe it can be, obviously somehow I have to omit this S at the moment, so there is another option, I may have lambda. Okay, and using this grammar, if we start designing a particular say particular uh, string, what can be a particular string from this grammar? For example, let's let's uh, try to write it from the very beginning. So S can be written as say written as like this, ASBS, as we have seen. And now let's do one thing. Let's just enlarge this S. Just we want to explore this S part. So I can write S, this S as again ASBS. So ASBS, and obviously other things will remain same here. So this will be A, and in this side I have a B. Right. Now let's do one thing. Let's take the second S. Okay, the second S, and let's explore this again. So what I will get? I will get again ASBS, and in this side I have again BS, and in this side I'll have AASB, right? So it will be AAS and I'm sorry, capital S and B. And now let's do one thing. Let's explore the first is again. Okay, so I'll get again ASBS, and before this ASBS obviously I'll have two A, and after this I'll have this whole combination BASB. So I'll have a BASB and S, right? Now you see what I can do. I can omit this particular part from the this particular string. Obviously I don't want to explore more, so let's vanish this one. I'll vanish this one. I'll vanish this one. I'll vanish this one, and I'll vanish this one. How? Obviously by using S2 lambda, this production rule. So 5 times I have to use this anyway. So as a result, I will see that this all the S vanishes, and ultimately what I will find out, the string that I will get is something like A, then B, then again A, then again B, then B, something like this, right? Now you see, if you think that what if I consider that let's take that A is equal to opening brace, and if I consider B as closing brace, as a result what I will get? I'll get something like this. So what is this? What is this? This is what I can say balanced parenthesis, right? Now you see that means the grammar that we have used here is basically used for generating any string in a mathematical formula of a type of string where I'll have a balanced parenthesis. Now assume that this is your grammar and I want to design my recursive descent parser that will parse a balanced parenthesis. I mean, it will basically check first that whether the parenthesis is balanced or not. If the parentheses are not balanced, then it will reject the string. Now, before we see that how a LLM parsing algorithm is working, you have to remember two things. That every grammar, what we know that in any grammar we have two things. Number one is what we call terminal, and number two what we call non-terminal, right? These are two things. Now always remember, in case of recursive descent parser, that for each and every non-terminal we write a recursive function. So this is very important point, that always remember that in recursive descent parser, for each and every non-terminals, we write a recursive function. Okay, so this is very important point. So I mean, if different type of MCQ come, maybe this type of the MCQ may come from this type of small points. That's why I'm saying that this is very important. Anyway, so that means in this particular grammar we have only one non-terminal, that is capital S. So we'll have a recursive function for this S, and how this works, let's try to realize it. As I told you that for each and every non-terminal there will be a recursive function. So you see, that means what about these terminals? So let's see. So if we write a recursive function for capital S, then how it will look like? So let's write it first and then we will explain. So assume that we have a function S, capital S. Okay, just writing a function in form of just like a C language. Okay, and you see, the first thing is that always remember one thing, that your input is something like a balanced parenthesis, right? So it's something like it's given like in this way, like we have a balanced parenthesis, something like this. Maybe this is a balanced parenthesis, right? It is a balanced parenthesis, and what we know that there is a look ahead, which actually there is a read pointer which points the characters one by one. So this is character number 1, this is character number 2, character 3. In this way, this is forming a whole string, right? And this is actually what we call look ahead. Okay. So accordingly, I can write in this way that if look ahead equal to, we all know that in this particular grammar, if we explore any s, the first terminal that will come in the, after exploring that is a, that is basically the opening brace. It has to get. So that's why I have to check whether the first thing is opening brace or not. If it is not opening brace, there will be some issue. So we will realize it later. So that means if look ahead is equal to opening brace, then what we will do? That means it is following, it should follow a grammar like this. The production looks something like this. And what I have written? AS, BS. That means there is a chance to explore this S and the last S from the current S, right? That means the first thing that we will do, basically we have to consume this particular symbol opening brace. And how we do this? We call a function, another function, say match. So we'll define this match function later, match opening brace, like this. And then what I told you, that there is a chance that I can explore this S again. So that means I'll have a call of S function here again. And you see, the function is called within the same function itself. And here the recursion comes, right? And that is the reason why we call it recursive descent parser. Anyway, let's proceed. And after, if I consider that this particular function call has already explored the whole path from this S, and somehow, definitely according to the logic of function, we all know that if the exploration starts from this point of a particular S function, at the end, after exploring everything through this function, this S, it should come back to the function from where this S was called. So when the control will come back to the function, then after exploring the whole thing that I will get through S, for example, like this S, I've explored this one. So after exploring the whole thing, the control should come back to here, and definitely there should have a B. If there is no B, then it is a problem, right? So let's see, that means I must have another match function which will check for the closing brace. If there is no closing brace present at that moment, definitely there is an error. So we will define that error in the match function. Okay. And anyway, still one thing is left, that is exploration of the last S. So this is done, right? So if the lookahead is opening brace, then it's fine. Now if the lookahead is not opening brace, then what to do? I mean that you have started with this opening brace and you have seen there is a closing brace. And if there is a closing brace, definitely that means whatever you have seen, there is the corresponding opening brace you have seen. So that means the whole thing has been explored. The whole thing. Like you started with opening brace, for example, and ultimately when you will see this closing brace, that means you can assure that okay, at least this part is correct, right? So I can go back to the previous function, which is basically taking care about the whole thing. That means that if the lookahead is not opening brace, definitely there is only one option, there will be closing brace. So you will come in else part and I should return to the previous S function from where this exploration started. So this is what actually definition of the S function can be. Now one more thing is left, that is the definition of the match function. So how I can write the match function? I can write a simple, something like a C logic, like for example, say void match. Okay, void match, and then basically I will check whether the okay, by the way, there I must pass some character over here. I'm sorry. We have this function is basically called by value. I mean, like a character is passed, so I must have a char ch, right? So if, what I can say, that if the look ahead, where basically we are pointing, is equal to the character, then I must consume the character. And how we can consume? We can call a function getChar. We all know that in a C language there is a function getChar, and that I can use. So I can simply write look ahead equal to getChar, something like this. Just I'm writing a probable code. It's not exact code that I'm writing. And if it is not true, if it is not the character, that means I am looking for a open closing brace, for example here, but somehow I'm getting an opening brace here. Definitely there is an error, right? So that means if they doesn't match, definitely I should raise an error, and maybe I can write a print statement, printf error, something like this, right? So in this way we can explore the match function, but yet still it doesn't end. The reason is that from where this S function will get called, who will call this? Like if I consider a simple C program, I must have a main function, right? From where the basically the exploration will start. I mean, I'm saying that okay, this S is called sorry, this AC is actually exploring this part, this AC is exploring this part. So how this S to ASB is started? Someone must call this S, right? So that means side by side we must have a main function also, right? We must have a main function, and that main function can be something like, basically it will call the S function. And what we know, that again from the concept of function, that after exploring whole thing, the return control should come back. And we all know that in any string, whatever the parser may be, one thing is common, that any string is followed by a dollar, right? That means if the string is correct, if everything is correct, that at the end, when the exploration will get completed, that means all the characters will get consumed, the look ahead should point over here. That means when, if the string is correct, then when the control will come back to the main function again, the look ahead is pointing over here. That means I can check it, that if the look ahead is exactly pointing to dollar, that means definitely everything was correct, and that's why look ahead is pointing to dollar, right? So that means here I can say that okay, that if the look ahead equal to dollar, then okay, say for example print okay, else there will be some error, something like this. So this is the whole scenario. I know this is the whole program actually that I have written, almost you can say, that for a recursive descent parser. So your program will start from here, the parsing algorithm will start from this main function, it will start exploring this S, and recursively it will find what, basically how we can find out this whether the particular string is correct or not. Now, to realize this, how exactly it is working, I think we should go through an example so that we can understand that in which order whether this particular algorithm is working correctly or not. And to do this, let's do one thing. Let's take a very simple, very simple string, for example, something like this, as I given over there. That suppose that we have a string something like opening brace, closing brace, again opening brace, again closing brace, and closing brace, and it will be obviously ended with a dollar, right? So this is a balanced parenthesis, we can easily understand. So if we try to explore exactly what function is being how the function calling is happening, say the lookup initially pointing to the first character over there, right? And assume that we started from main. So just if we want to explore that how the main function is exactly working, so suppose that we have a box that is representing the main function, okay, and it will what it will do, it will first call this s function, right? So this main function will call an s function, right? Now you see that we will we can easily understand that there is a multiple times different s function will be called. Actually they are different clone of the s function, right, according to the concept of recursion. So that's why we have to keep track that under which clone it's working. So I'm writing s as suffix 1, okay, it's clone number 1, the s function of clone number 1, okay, something like this. So clone number 1 means that this is function. So assume that means this is function will get executed, and the first thing is that lookup equal to opening brace. Let's see, the lookup is, yes, the lookup is opening brace. So if the lookup is opening brace, then what is written, that match, then s, then again match, then s. So the first function that will got is match opening brace, and you see in the match opening brace it's given that yes, lookup is the character, the match is same, basically lookup is the same character, the opening brace, right? So that's why it's okay. So it will consume the character. As soon as it will consume the character, what will happen, the lookup will be shifted towards right once, right, and the job of the match function completed, it will come here. And what will happen, from here another s function will get called, right, another s function will get called. So like your look ahead will be shifted towards right, and from this clone number s, clone number 1, another clone number 2 will get called, right? Clone number 2 will get called. So clone number 2, I'm not writing the match function calling match. I'm not actually keeping track the calling of match function here, because we can easily understand that only once match function will be called, either it will consume the character or it will throw an error. So that's why I'm not keeping track about the match function, but I'm keeping track on the s function, because the recursion is actually vital, right? So the s function of the second clone is what, second clone means actually the same behavior and the totally different function. So that means for the s function of second clone, again the code will start from here. So with respect to the second clone, it will again check whether lookup equal to opening brace or not. Yes, lookup is equal to opening brace. So that means it will enter and it will match, obviously it will match the character, right? And then what will happen, after matching this, it will go towards right once, right? And then what will happen, again another s function will be called. So from this s function, second clone or third clone will get called. Now with respect to the third clone, you see, from the point of view of the third clone, the look ahead is pointing to the closing brace, right? Now from the point of view of third clone, this look ahead equal opening brace will be false, because now look ahead is pointing to closing brace. So it will come in else and it's written just return. What does it mean? It means that the second clone will now, I'm sorry, the third clone will now return to the second clone, because we all know that from where the function was called, there it will return. Anyway, I'm just numbering it so that you can understand what is the exactly the order of calling and returning. Anyway, so now question is that in which particular line of the second clone it will return, from where it was called. It is called from here, right? From this line of the second clone. So naturally the return will be in the next line of the second clone, that means over here. As soon as the third clone will return to the second clone in this particular next line, and in the next line we have a match function here again, which is given match closing brace. So again match function will be called, but this match function is associated with second clone. Remember, third clone has already returned, there is nothing to do. Now with respect to closing brace, this match function will be matched, right? Because you can see it is a closing brace. And what will happen as soon as it will get matched, the I'll have a the shift of the look ahead towards right. At the same point of time, the match function completes its job, and again another S function will work. And with respect to this S function, again a fourth clone will be called from here, right? A fourth clone will be called. And what with respect to the fourth clone, what is the status? The status is, it is basically pointing it's basically pointing to this look ahead, right? To this look ahead. From here it was here, from the first clone match. Just a minute, let me just review it once. For the first clone, yes, look at here, match here, and then is again look at here, match here, is look at return. Then from here to next, this S was called, and look at here. Okay, so now when in the fourth clone, this fourth clone will see that with respect to the fourth clone, this look at is again opening brace, right? So it will basically uh, enter in the if with respect to fourth clone, and it will match this opening brace. Yes, it is consumed, it will be matched, right? We can easily see it will be matched with opening brace. And then what will happen again, another S function will get called. So after matching from over here, another S function, that means from S4 to S5 will get called. Now see from the point of view of fifth clone of the S function. S5 means fifth clone of the S function, right? So from the point of view of fifth clone, since anyway it was matched, that means it will come here, right? Okay. So from the point of view of fifth clone, the look ahead is pointing to closing brace, and with respect to the code, if look ahead is opening brace, it will definitely become false from the point of view of fifth clone. So it will come in else but and return. So return means, that means this S5 will return to S4, because from S4 it was called, and from which line? Obviously from line this one. From this one this S5 was called. As soon as it will return, now the match of this closing brace will be called from what? From the S4 function. From the S4 function, the match function will work, because it is right now pointing to closing brace. So match closing brace will work, and since it works, it will go this side, right? I mean it will shift towards right, and then again, I'm sorry, then again after matching this one, what you can see, another exploration of S is there, like this one, right? This one. So that means from S4 again another function will be called, that is S6, right? S6. And this S6, what it will do, with respect to S6, you see it is pointing to closing brace, so there is nothing, again lookup will be false and it will return. That means S6 will now return over here. By the way, let me write the numbering it. 6, it is 7, it is 8, and it is 9, right? So S6 will return to S4, which line over here. So basically everything is completed in the if part of this S4 function. So that means naturally, if nothing is present to to execute, definitely S4 function completed, and it will, the control of the S4 function will return back to the calling function. I mean the function from where the S4 was called. From where S4 was called? S4 was called from this particular S2, and from which line? Obviously from this line, because you see from the first S exploration of S2 was done toward S3, the second exploration of S, this one, was done towards S4 from S2. So anyway S4 will return over here, and again you see with respect to the S2 function there is nothing left. From here with respect to S2 function, if you see that S3 return in this statement, I mean the third clone, and the fourth clone return over here. After returning over here there is nothing to do execute. That means the job of the S2 function also completed. So what will happen? Now S2 function will return again. The question is that where it will return. Let's see. This S2 function was called basically from the first clone. That means from, you know, in this particular line, right? From, with respect to first clone, if you see that from here the S2 function was called, naturally it will return here, and after returning back again a match closing brace will work, right? And you see right now you are pointing to closing brace. Yes, you are correct. This is correct. So that means the match of closing brace will work perfectly. As soon as this match will work, then the read pointer, I mean the lookahead, will shift it towards right again, and now it is pointing $2. Okay, and in this situation another S function will be called from where? From this clone number 1. So from here, I mean let me just return it over here, and then from here another memory will be created for the functions for the another clone, and that is clone number that is basically clone number 7, right? Clone number 7. And with respect to clone number 7, if you see that clone number 7, the lookup is now pointing to $, and with respect to clone number 7, that means definitely this condition will be false. If this condition is false, in the else part it is nothing but just to return. That means immediately this S7 will return to S1, right? And where it will return? Obviously return over here, because from where, from here this S1 was called, right? Anyway, I'm just omitting this, all this line that I've written here. Anyway, so after that means you see with respect to the point of view of S1 function, that means the first clone, the job is completed. There is nothing left in the if part. That means what will happen? Now the first clone of the S will return where? It will return to the main function, because from the main function it was called. So that means control will come back to the main function and it will come in this line, because from this line the main function, from this line of main function the first s clone was called, and when that clone will return to a main, obviously it will return in the next line. And in the next line we have a checking that if lookat equal dollar, let's see, yes, lookat is pointing to dollar, that mean the string is okay. I mean, I have written here okay, so definitely there is something more, the other steps that is there during execution of the particular string will work. But my point is that at least it will not print that there is some error. So this is how you can say the particular recursive descent parser works for a particular string. But you see, we have discussed about what will happen in case of correct string. But if we just draw a situation where I have something wrong string, for example, let's take a very small wrong string, for example, like this, like opening brace, say opening brace and closing brace. That's all. Okay, and obviously ended with a dollar. So initially your look ahead will point over here, right? And this is not a balanced parenthesis, so definitely the recursive descent parser, if this programming is correct, then the recursive descent parser should raise an error. Now let's see whether it will raise an error or not. So as we have seen already in the previous example, we will start from here, and we have a main function again, and that main function will call a s function, and we are representing at, obviously the lot of recursive function may be there, so the first clone of the s function representing as s1 again. Okay, and with respect to the first clone, what happened? The lookat is pointing to opening brace, so condition is true, so I'll have a match opening brace. Yes, match opening brace will be correct because right now you are pointing to opening brace. So naturally what will happen? This will, the opening brace will be consumed, and your read pointer will point over here, right? At the same time, after matching it, obviously the control will come here, and this particular line will get executed of the first clone. That means from the first clone a second clone will get called. So let's call it. A second clone is called from here. Now see, from the second clone point of view, what happened? The second clone can see the lookat is pointing to opening brace again. So from the second clone point of view, again, this lookat is correct. So that means the match opening brace will work fine. That means after consuming the character, the pointer will point here, right? And what will happen after matching this closing opening brace in the second clone of the s function? This particular line will again execute it. What does it mean? It means that from second clone of the s function, third clone will get called again, right? So that means from here a third clone will be called. Fine, okay, let's call it. So I've called a third clone of the s function, and so this is basically like this, right? Now with respect to third clone, you see, with respect to third clone, by the way, yes, with respect to third clone, you see what will happen. From the point of view of third clone, we can see that lookat is not opening brace, because right now lookat is closing brace. So the condition will be false and it will come in else part and it will return. Means the third clone will immediately return to the second clone. Which line? Obviously in the next line of the second clone over here, and there this match closing brace will work, and yes, this is correct, closing brace is working fine. As soon as match closing brace will work, what will happen? That means closing brace will get consumed and this pointer will be shifted towards right. right? Fine. And then what will happen? After matching again another s gets called. That means from this current s2 function where this matching was working right lastly, another clone will get called. Say for example fourth clone. Fine. Let's call it again. Now see, from the fourth clone point of view, that your read pointer is pointing to dollar, and you will just first time this s4 was called, so definitely look at is pointing to close, look at equal opening brace will be false, it will come in else part, so immediately it will return. That means immediately this s4 will again return to s2, right? Fine. So let's numbering it. And where it will return? Obviously in this last line. I mean everything is completed of the S2 part. So what will happen? Now S2 will return to S1, right? And in which particular line? From which line of the first clone the second clone was called? Obviously from this particular line, right? That means just let me remove this part so that you don't get confused. That means just try to understand from the first clone point of view. From the first clone point of view, from this line the second clone was called. So naturally the second clone will return in the next line of the first clone. That means match closing brace will get executed. That means I'm expecting there will be a closing brace. And what will happen? We will see that there is a mismatch, because right now you are pointing to close dollar, but I'm expecting there must have a closing brace. So there is a mismatch. Since there is a mismatch, definitely there is an error and it will throw this error. So the recursive parsing, the parsing basically stops at that moment because it has thrown this error. And you see, yes, we are correct. I mean, we are correct means the string is really not balanced. The parentheses are not really balanced. That means it should throw the error. So you see, we have taken two examples. One is correct string, one is wrong string. In both cases the algorithm is working fine. That means it can be a solution for designing a recursive descent parser for something like, balanced parentheses. So not only balanced parentheses, for any type of grammar or for any type of language you can use recursive descent parser. Just you have to remember one thing, that we have to write recursive function for each and every terminal present in that particular grammar. Okay, so in this way basically recursive descent parser works. So basically we have completed, if you go back to the the tree of the parser here again, that means we have completed both things. A recursive descent parser and LL1 parser. That means the top-down parser without backtracking is completed. Anyway, these are not in this syllabus, so I'll not go through this part. So that means now what we can do, we can start what I can say bottom-up parser. So now we will start with bottom-up parser, and the first thing that we will do is what we call operator precedence parser.